Sequential means the operations are performed in a sequential manner. For example, if you take a traffic lamp, the traffic lights will operate in a sequence manner. So how can we describe that? Is the red light is on for 1 minute, or green light will be on for 1 minute. After the green light on, after 1 minute the red light will be on. Means that the state of each light will be occur up to 1 minute. So based on it, the states of red light and green light, along with the inputs and outputs of each state. For example, you can take two states here in a traffic light example, state 0 and state 1. In state 0, red light will be on for 1 minute. After that, the green light in state 1, the green light will be on for 1 minute. So there are having only two states here. After the state 1, again go to the state 0. If later I will go to the state 1. Okay, this is a cyclic manner. This operation is called as a sequential operations. Now we can take an example here. So in this diagram you can observe that we are having that, as we discussed now, right? There are two states. It is having a 0th state. In this state the red light will be on. In this state the green light will be on. So the red light will be on for 1 minute. Here the red light is the output. State is nothing but here we are having the inputs, state 0. If the state 1 is occurs, input is on, red light will be on for 1 minute. If the state 1, coming to the state 1, the green light will be on for 1 minute. Whenever the 1 minute is over, this condition is transferred to the next state. Currently we are in the state 0. After 1 minute occurs, the condition is transferred to state 1. Okay, what is the state 1? It is a green light. Green light is on for 1 minute. After that, what will happen? The state conditions transferred to the state 0. When 1 minute is over, the red light is on for 1 minute. The state is transferred to condition is transferred to the state 1. So this is a cyclic manner. This is an example of sequence for traffic lights. Now, so how we can implement this sequential function charts, state and the transition diagram. First we can start with the transition state is start and end with end. Okay, these two are compulsory, we have to follow. So before going to the state, respective state, for example state 0 and state 1 we discussed, right? We have a transition condition in this sequential function chart. That transition condition is represented by the horizontal line. The transition condition is represented by the horizontal line. Each and every stage is connected by the, for example, initialize the process, connect to the state 0. It connect to the state 1. Okay, each connecting line between the states has a horizontal bar. Okay, this is a horizontal bar which is discussed here. The green color represents horizontal bar. From state 1 to end, it is having a horizontal bar. Okay, this horizontal bar is considered as called as transition condition. Coming to the state 0, state or it is called as a step. State or step. So this state is having, whenever the state occurs, the respective output, as we discussed, state 0, the red light will be on, the red light will be an output. So we are having a output here. For state 1, before going to the state 1, we are having a transition condition. Okay, based on transition condition triggering, it comes to that state 1. Okay, this state 1 is having another output. Two states that never directly connected, that must be always separated by the transition condition. Okay, it does not look like this. State 1, state 2, these two states you are not able to connect this. Okay, these are wrong. There could be a transition condition between the two states. Then only it can transfer the condition from state 1 to state 2. So when the transfer condition outputs, coming to the outputs, how can we connect the outputs is outputs of any state are represented by linked by the horizontal line. Linked by the horizontal line. We see here this is linked by the horizontal. Outputs are linked by the horizontal line and states are linked by the vertical lines. Here states are linked by vertical lines and outputs are linked by the horizontal lines, as well as a transition condition also linked by horizontal. You can see here by this figure we can represent the sequential function chart. Okay, as we discussed, the sequential function chart starts with the initialization of this process denoted by the start and end of this process denoted by the end block. In between we are define the process, we define the sequential operation. What happens actually is in step 0 we are having the two states or steps. This is called as the states or steps. In step 0 we are having the two steps and three transition conditions here, but only that the outputs are linked to the transition conditions of input 1 and input 2. There is no transition condition linked for the output or linked for the this transition condition, that is input 3. Means that when in case of step 0, when input 1 occurs, this is the input 1. When input 1 occurs, then step 0 is realized that it is input is triggered, so output will be on. Output will be on. In second case, in step 1, when the step 1 has to be realized, when the step 1 is realized, because that the output 1 is occurred, so when the step 1 is realized, when the input 2 is triggered, when input 2 is triggered, the step 1 is realized, so that means when the output 1 is done, the output 1 is done, the step 1 is realized that and transfer condition to input 2, the step 1 is realized that output 2 is occurs. Enable the output 2. Enable the output. Now we can implement this. In ladder diagram. This is sequential function chart. How can we implement this in ladder diagram? Means, so there is start and end. End is there in ladder diagram, but start there is no start process here in ladder logic. Directly we start with the input 1. When input 1 is occurs, what happens? The step 0 is realized that input 1 occurs, so that output 1 is on. When the input 1 is triggered, so that output 1 is on. Now coming to the step 1, the step 1 related to when the step 1 is realized that output 1 is done as well as the input 2 occurs. Both the things has to be happen. In such case, it depends upon the output, it depends upon the output 1 as well as the input 2. Otherwise, it is not depending on the output 1. Simply we can write as input 2 as well as output. But in this case, the step 1 is realized that when the output 1 occurs as well as the input 2 occurs. So we have to include that this is output 1 as well as input 2. Okay. output 1, input 2 and output 2. Here we are writing. So this is the equivalent layer diagram for the sequential function chart. So next is the branching concept. We are having two types of branching operations here. One is a selective branching. Next one is parallel branching. Selective means we are connecting a series. By the name itself, we can say that this is a parallel branching. Here for selective branching, there is an example of selective branching. This is an example for the selective branching. You can observe that we are having the states. State 0. State 0, there is no transition condition. So we are not considered this state. Okay. But this transition condition occurs based on the output 0. This transition condition also occurs based on the output 0. This transition condition occurs based on the output 0. Okay, we are having the three states here: state 1, state 2 and state 3. This is having the no transition condition here. Not bothering about this state 0 occurred or not, okay. But the output is connected, means that state 0 is realized that output 0 is on. So when this state 1 occurs is if the state 1 occurs if the transfer condition input 1 occurs. The state 1 occurs when the transfer condition input 1. This is the transfer condition. The transfer condition input 1 occurs. Okay, so based on this, if in the same manner, but if input 2 occurs, state 2 occurs. If input 3 occurs, state 3 occurs. Okay, but these three transition conditions are input to output 0. Now, how can we implement the ladder logic for this sequential function chart? Is this is a series connection. So series selective branching. How we implement, as we know that this is linked to output 0, means that this is output 0, this is input 1. If both the conditions are satisfied, then only state 1. This is a state 1 output. Okay, when output 0 occurs, input 2, then state 2 output will be on. Next one is when output 0, when the transition condition input 3 occurs, state 3 output will be on. Okay, so this is how we can implement the selective branching concept in series connections. Next thing is parallel branching. Here you can see that the state 1, 2 and 3 occur simultaneously when transition input 1 occurs. See, this parallel branching is represented by the double horizontal line. You can observe that this is a parallel branching. Okay, in series you can find out that you are having the only single line, but in case of this parallel branching we are having the double horizontal line. So what happens here, we are having the three states. This three state occurs when input 1, based on the transition condition input 1. So when input 1 occurs, then the state 1, state 2 and state 3 are simultaneously on or realized that. Okay, how can we, this is based to when based on the output 0. So when output 0 occurs, the input 1 occurs. When output 0 occurs and an input 1 occurs, the three states will be realized that, I mean on. How can we implement this is input to output 0 as well as a input 1. The three states are based on the input 1 means how can we connect this? State 1 output, we are connected in parallel. This is state 2 output and this is state 3 output. We have connected this parallel. So this is the equivalent diagram for the sequential function chart parallel branching. When input 1 occurs and output 0 already occurs in the previous state, that is the state 0. Okay, now the transition condition is transferred to input 1. When input 1 occurs, the three states will be on. This is an example for parallel branching.